In problem number 7, we're given the equation for the rate at which urea is removed from the blood of a patient when during the dialysis. And this rate depends on the time t since the start of the dialysis and the volume V of the patient's blood. Now, what we're asked to do is to calculate the derivative, the partial derivative of this rate R with respect to the volume V at the point 0, 2, where 0 is the value for T and 2 is the value for V. Looking at our function R of TV, the rate at which the urea is removed from the blood as a function of time t and the volume v, when we take the partial derivative with respect to v, the value of the variable t is kept fixed. And so t, for the purposes of calculating this partial derivative, is just some constant whose value has not been specified. Now, we see that the function is a product of two terms containing the v variable. The first term is 3000 divided by v, and the second term is e to the power negative 10 tv, exponential term. Because the function is a product of two terms, we will need to use the product rule to calculate the derivative. The product rule says that when we differentiate a product of two functions, the derivative is equal to the derivative of the first factor multiplied by the second factor plus the other way around, the first factor multiplied by the derivative of the second factor. The derivative of the first factor, 3000 divided by v, is negative 3000 divided by v squared. And just to remind you where this is coming from, so if you write 3000 over v as 3000 multiplied by v to the power negative 1, then you can calculate the derivative using the power rule. The derivative with respect to v of 3000 times v to the negative first power will be 3000 times negative 1 times v to the negative second power. And of course, v to the negative second power is the same as 1 over v to the positive second power. Overall, we get negative 3000 over v squared for this derivative. Okay, so going back to the calculation of the partial derivative of r with respect to v, I calculated here the derivative of the first factor. Now this derivative will have to be multiplied by the exponential factor, the second factor. And then to that, we will have to add the first factor, 3000 divided by v, multiplied by the derivative of the second factor, which is an exponential function. And not only it is an exponential function, but the exponent is not just v, it's a function of v. And therefore, for calculating the derivative of this exponential term, we will have to use the chain rule. According to this chain rule, the derivative will be e to the power negative 10 tv. This is the derivative of the outside function, e to the power x, let's say. But x now is negative 10 tv. X is being replaced by negative 10 tv, and so by the chain rule, we need to multiply by the derivative of negative 10 times tv, which is negative 10t. Okay. Now, we could simplify this a little bit, but considering that what we need to calculate is the value of this partial derivative at the point 0, 2, and so t, we will substitute 0 for t and 2 for v. And when we plug in 0 for t, the second part of the partial derivative that we just calculated, this whole thing, this whole term, will turn into 0. Why? Well, because we're multiplying by t, and multiplying by 0 turns all of this into 0. And so we only need to worry about the first part, this part right here. Now when t is 0, the exponent of the exponential term is 0, and e to the power 0 is equal to 1, and therefore the value will be simply negative 3000 divided by v squared, but v is 2, so it'll be divided by 2 squared, negative 3000 divided by 4, and that's negative 750. And that is the answer for this problem.